to early 1970s. Right, it's slowly reducing. And if you look at these are the main technologies that are used to reduce CO2 emissions. First one, if you look at from the carburetor, they went through EFI, that is electronic fuel injection, and then by using turbochargers or gasoline direct injection, variable valve timing, so the engine output was improved. And then the next one, if you look at here, which is the hybridization, and finally, if you look at here, ethanol fuel, right? It's a big contributor now for CO2 reduction, right? So that's going to the biofuel like ethanol is going to bring down your CO2 emissions. That is CO2 emissions, right? And so this is the worldwide CO2 uh, contributors, emission contributors. Actually, if you look at China is the first, actually contributing to around 27.21%, and India is around close to 7%. That's 6.82. Right, and this tells about how much energy we are consuming. Right, it's a direct indicator of the energy consumption. So it very well tells that now we are consuming more energy, right? So that could lead to more amount of CO2 in the atmosphere. Right. How to decrease CO2 now? No, so that's a big challenge now. What all automotive industries have. So the recent trend being, if you look at industries have started switching over from a bigger size engine to smaller size engine. So they are downsizing those. So that is now the trend of the automotive industries. And in addition to that downsizing, they are also going for hybridization. Right now, we would have come across micro hybrid and mild hybrid, uh, which are now large spoken by the automotive community, right? So that could bring down the CO2. The next one being the technologies which you are already very familiar, like the turbocharger, which is now mandatory from Euro 4 norms, and uh, increasing optimizing your valve timing, cylinder deactivation, reducing the accessory load, right? This also can bring down your CO2 emissions. So this makes the engine's output better, right? So that can increase your power to weight ratio, right? And if you look at, we have biofuels also in the list, right? And efficiency improvement by the transmission. So these two are interlinked, right? Increasing the number of gear ratios in the transmission. Right. So these are some of the ways to reduce the CO2. More or less, if you look at, when I say that we are going to reduce the CO2, then parallelly, what the advantage you are going to get is lesser fuel consumption, which means that your efficiency is going to improve, right? Or the engine performance is going to be better, right? So, so. So another way, I would also put. I used to tell my students, the development of engine is mainly contributed by the emission norms. Right? If emission norms doesn't come into picture, we would still drive the old engines. We will not be more concerned because of cost effectiveness. Right. So these stringent norms actually put, though they put uh, uh, stumbling blocks on the way. The automotive industries, uh, develop new technologies to cross these, stumbling blocks. Right, and few figures about the Indian automotive industry. Right, India is the largest three-wheeler manufacturer in the world, and it is the second largest two-wheeler manufacturer in the world, or it's the second largest two-wheeler market. And India is the seventh largest passenger car market in the Asia, or the 10th largest in the world. And we are in the fourth largest, coming to the tractor, and fifth largest in the commercial vehicle. So if you look at the figures, actually, these are all, in the past 2 decades. We are able to get into the world arena, right now. We are developing we have started developing new technologies in India itself. And as the aspiration of the people goes high, the purchasing power of people also is going high. A lot of vehicles are being sold in India, and parallelly, if you look at the export is also improving, year on year. So these are all the main contributors for the increased sale of or the increased manufacturing of uh, uh, automobiles in India. Right, and this slide tells about the challenges what we face today. Mostly now it is for the automotive industries. So I've divided into two. One is on the engine technology, and another one is on the fuel technology. So on the engine technology, the major challenge is the energy conversion efficiency. As I told, now people are working to improve the efficiency close to 50 or 52%. Right, and a lot of journal papers are also available. You can refer to it. New technologies are being implemented, something like waste heat recovery. Right, so that could add to the efficiency, so your overall efficiency will be better. The second challenge is lower tailpipe emissions, right? So people started speaking about the CO, NOx, and particulates, and these days we are also speaking about CO2, right? So that also will add up. Then the next one is the power to weight ratio, right? The lighter the engine, the less will be the fuel consumed by the engine for it to propel from one point to another, right? And the last one, but not the least, is the durability, right? We look at the service life of the engine. So these are all the challenges faced by the automotive industry. And if you look at the fuel industries, the first challenge is low carbon fuel technology, right? So a lot of people are working on low carbon fuel technology that can reduce CO2. One such technology could be a bio-based fuel. So um, though we do a lot of research related to bio-based fuel, and if you look at the literature, it may date back to 4 or 5 decades back, right? So for more than 40, 50 years, we are trying to explore the bio-based fuels, but it may take more time for it to reach the commercial point, right? So that also could be one big challenge, right? And the last one will be the reformulation, which the fueling industries are doing now, right? And storage and dispensing is going to be the other challenge for the fuel industries. So, on the nutshell, these are the major challenges actually faced by both automotive and fuel industry. Right. So the solution, one of the solution is the biofuel, as I said. What are biofuels? So biofuels are derived from variety of sources, right? It can be from an edible source or a non-edible source, right? And when uh, when fuels like those that get their energy content from the sun, or something like or I would say that, if you derive it from a plant, right, which takes energy from the sun, then we call it as a renewable, uh, right? So the fuel derived from the plants, or or a part of a plant, or a bioderivative, I can say the bioderivative, right? We call it as a biofuel, right? Some of the good examples are, alcohols that are taken from sugarcane or any other starch-based vegetable, right? It can be a corn or potatoes, right, or some kind of vegetables or vegetable waste. So you can generate alcohol from a bioderivative, and oils that are derived from seeds of plant, right? Vegetable oils that are derived from seeds. And though we can't directly use these oils, actually, we need to do some process, right? And then after that only it will become usable, right? And looking at on the other side, fuels like alcohol, they can be readily mixed actually with the fuels. So you can overcome some of the drawbacks of oils, right? So these have distinct advantages when compared to that of oils, vegetable oils, right? When we speak about ethanol, when we speak about alcohol, there are two main alcohols that are very commonly used for transportation. One is going to be your ethanol, and the second one is the methanol, right? So many of you must be aware of ethanol, uh, right? So it is also available in beverages, right, and drinks and beverages. So when I say ethanol, um, it's not only used for drinking purpose; it is also used as a fuel. If you look at the worldwide, ethanol is used as a fuel. From the percentage point of view, no, the application on the fuel side is more than the consumption side, right? So that is one of the successful fuel, bio-based fuel, right? And it has been considered as an alternative fuel for many reasons. In India, it is produced from sugarcane waste, right? Or the waste that is generated from the sugar plant. That's called as molasses. In US, the derive it from the corn, right? So basically, these are all bio derivative, right? So it is more renewable nature actually. So it is less toxic. Ethanol is less toxic when compared to that of methanol, right? Methanol consumption may lead to death, or even slight poisoning of methanol. Slight poisoning of methanol may lead to loss of vision, right? So this is more toxic. Methanol is more toxic when compared to that. Ethanol is less toxic, right? And even byproducts, when you burn ethanol, ethanol contains carbon and hydrogen, right? It's basically a hydrocarbon. When you burn, actually, the partial derivatives that are created by incomplete combustion, those are less toxic than compared to that of methanol, right? And methanol creates formaldehyde, which is carcinogenic in nature, right? Whereas ethanol generates acetaldehyde. It's not so toxic, compared to that of formaldehyde, right? So ethanol is biodegradable, so it is safer to the environment, and it has wide flammability limits. So these are all the reasons, why ethanol is considered as a renewable fuel. It's a main reason. And so I have given here some of the properties of ethanol, and compared it against gasoline. The major problem lies at two or three points actually. So suppose if you look at one of the major drawback is the calorific value. You can look at here for gasoline, that is close to 43 megajoules, whereas if you look at it, it's slightly above 50% of gasoline, right? It's around 28.8 megajoules per kg, right? Maybe around 60% of the gasoline. This is the first major drawback. And the second one is here, right? The latent heat. When you look at the latent heat of ethanol is around 880 kilojoules per kg, whereas gasoline is around 324 kilojoules per kg. So these are the major contributors, for the difficulty, right? And another problem that I have not mentioned here, that is also another important property, is hygroscopy. We call it as a hygroscopy. Ethanol is more hygroscopic than gasoline. So hygroscopic property also leads to some other problem, right? It will create an issue while you are using it as a fuel. So these are some of the issues with ethanol. Maybe I have a detailed slide on the drawbacks of ethanol. But though when you look at when you look at the properties, ethanol has some drawbacks. The advantages overweigh your disadvantages, and that's why there is a drive towards ethanol. Right now, government has started taking decision to increase the ethanol blend ratio in the gasoline, and they want to achieve around 20% by 2030. Right. There is a drive still. There is a drive to go towards ethanol, and so these are some of the properties I've given here related to ethanol blends. E10 states that 90% gasoline and 10% ethanol, whereas E20 is 20% ethanol and 80% gasoline. Right, and if you look at when the percentage of ethanol increases in the blend, the major problem starts again here. The calorific value of the fuel is coming down. Right, so this is going to create a problem in a vehicle. Right. So, India's national biofuel policy in 2018 has recommended a blending target of 10% by 22 and 20% by 2030. Right, till June this year, June, around 92.5 crore liters of ethanol has been supplied for oil manufacturing companies, and we are able to achieve a blend ratio close to 5.09% of ethanol with gasoline. Right, and see, such lower level of blending will not lead to any problem, because the variation in the calorific value or other properties is going to be smaller, because the gasoline property is going to dominate the overall fuel property. Right. So another good news is that few of the states like Haryana, Punjab, Uttarakhand, Bihar, and Karnataka, they are able to reach close to 8.5 to 9.8% of blending ratios. Right. They are closely reaching towards the 10% mark before 2022. Right, and the India's total ethanol consumption in 2019 is it's close to I think 3.1 billion liters, right? And you can see that the consumption ratio is slowly increasing, right? In 2019, it's 2018 it is 3.1, and 2019 it is 3.8 billion liters. And if you look at the production, that's close to 3 billion liters in 2019. So there is a shortage of around 0.8 billion liters. This is again imported. Right, though we have facilities, to generate ethanol, we still, import ethanol. So these informations are taken from the Economic Times here, I've mentioned here, right? And India has around 330 distilleries, which can produce around 4.8 billion liters of ethanol, right? So right now, we are producing 1.8 liter billion, lesser than the maximum achievable, right? And another main reason, why in India, why India could not why another reason, why India could not achieve higher ethanol production is that most of the sugar industries does not have distilleries, right, where you can generate ethanol and store it, because it involves huge amount of investment. Though sugar industries are very successful, but you require large infrastructure to store and maintain these fuels in the sugar industry. So that's a big challenge actually right now, and hope that in the years to come they will bridge this gap, and we'll be able to generate a lot of produce a lot of ethanol, so which will be self-sufficient for us. And see, we are speaking about Indian scenario. In Brazil, uh, application of ethanol has started very early. Right, in 1975 itself, they started the ethanol program. Right, and 2003 and 2004, actually, they were using around 14.7 billion liters of ethanol for blending in the fuel. So if you look at Brazil, they they started using ethanol as a blending agent, right from 2000, sorry, 1975. Right, and some of the popular fuels being E85, right, which contains around 85 percentage of ethanol and 50 percentage of gasoline. Right, here you can see that some statistics, again it is taken from some journal actually. So it says, clearly says that um, in 1981, they were able to reach around 25%. Remember, if you remember the previous slide, I was saying that 20% of ethanol by 2030, right? So this mark has been reached by Brazil in 1977 itself, right? So the main reason is why ethanol as fuel has become very popular in Brazil is because of the subsidies. Right, initially they gave a lot of subsidies for producing ethanol and using ethanol as a fuel, but slowly in the late 90s actually they removed all the subsidies. Right now there is no subsidy actually for ethanol based fuels. Right. So everybody knows that Brazil is the largest producer of sugar cane. Actually, what they do is they balance the sugar cane. Actually, 55% of the sugar cane is for alcohol. Right, they are spending around 55%, and the balance in producing the sugar. Right. So they have a very good ethanol program, which can directly, reduce the oil imports. Right. So there is no much loss in the dollar exchange. Right. And coming to ethanol, right. If you look at ethanol can be used as a fuel in two ways. Um, the first one being replacement of gasoline, right? Now, maybe in a small percentage, as we discussed in the earlier slides, maybe from 5 percentage to 20 percentage, right? And the other one is for improving the octane value of your fuel, right? And, when you look at the property of ethanol, if you closely look at, right, the octane value is very high compared to that of gasoline, right? So that's close to 100 most of the times, actually, right? And sometimes, what we do is ethanol is mixed with gasoline as octane boosting agent, like an additive. Right. So these are the two ways actually how we use. But if you look at the first way is going to majorly dominate, the years to come. Right. So India has potential to produce ethanol to the tune of 30 billion liters per annum. Maybe slowly in the years to come, slowly, slowly, the sugar industries, when they attach distilleries, soon in the near future, we'll be able to witness these figures. Right. So ethanol program in India, um, as I told the earlier slides, we started, during 2002 actually, right? There was a plan to put ethanol as a fuel. Okay, and you can see that, but seriously, it started from 2007, and here you can see the values are given up to 2016. Right, this is the fuel ethanol production, that is in billion liters, right? So that's close to 98.6 billion liters, that is being generated. So that's a cumulative, right? And here, if you look at the fuel ethanol production in billion liters, this is by different countries, right? How much they generate. So that if you look at US has the highest rate, you can see here around 58 billion liters, right? And in India, the value is close to zero point 0.7 uh, billion liters. I'm sorry, this is million liters. It's not a billion liters, right? And if you look at the ethanol share, if you look at the ethanol share, yes. And if you look at the ethanol share, this is what is uh, the distribution as a fuel. 30% of ethanol that is manufactured or produced in India, it goes to fuel or a fuel additive. Around 24% goes to the beverages, and we have around 3.5% goes to disinfectants, like your hand sanitizer, and 33% goes to the industry as a solvent, right? And so by 2030, I think we could reach this target, right? And again, these are taken from internet source. I don't know the reliability of this information, but still you can have some rough estimate of how much goes into the fuel, how much goes into the beverages, and other applications. Right. So this is another interesting slide that tells about the cost of ethanol. You can see here the cost of ethanol is around 39 rupees in 2016, whereas the petrol price is around 66 rupees. Right. When ethanol is now manufactured in abundant quantity, right, or when you interface distilleries, more distilleries with the sugar factor, I'm sure that you'll be able to bring down the cost by at least another 50%. Right, so they are very cheaper when compared to that of the fossil fuels. Right, and so this is ethanol demand. Actually, it's a forecasted demand. You can look at the 5% blending, 10% blending, and 20% blending. So this is by 2030. You can see here the demand is going to be 13.66 billion liters of ethanol during 2026. Right. Okay. So coming to this blending, right? Coming to this blending, we have two types of blends actually. One is a lower level blend, and another one is a higher level blend. If you look at the lower level blend, it goes up to 10% maximum, right? And if you look at the higher level blend, 85% is the maximum. And there are even vehicles which can solely run on ethanol, right? That's 100% ethanol. Right, or basically there are fuels which can run on any percentage of ethanol. So we call them as flex fuel vehicles, where you can change the percentage of ethanol, but still your vehicle will adapt according to the percentage of ethanol that is there in the fuel. Right. So so there is a study in 2003 that by Aragon National Laboratory, they found out that 2003 the use of ethanol as a fuel has reduced the CO2 equivalent of greenhouse gases by approximately 5.7 million tons. Right, so that is equal to the greenhouse gas generated by around 8,53,000 cars running on the road. Right, it's very sure that CO2 can be reduced by uh, using ethanol as a fuel. Right. So I'm just listing here some of the advantages of ethanol. Right. So ethanol has oxygen in it. Right. So the chemical formula is C2H5OH. So it has an oxygen already carried out in the fuel. So there is no which means that uh, the additional oxygen which is required from the air can be compensated by using the internal oxygen of the fuel, right? So the oxygenate or the oxygen in the fuel can help for improved combustion, right? And it has a very high octane number which can also help in increasing the compression ratio, right? So they go up to 13, right? And then the places like US and Brazil, you can see that since they use a very high percentage of blending, the compression ratio, they were able to reach up to 13, right? So which improves your efficiency. So we all know that the efficiency of the engine increases with compression ratio, right? So higher the compression ratio, better will be your engine out efficiency, right? So another advantage what ethanol brings in is higher volumetric efficiency, and this is especially achieved by the latent heat. Right, I told you that the latent heat of ethanol is around 880, right, kilojoules per kg. So what happens is that when the ethanol evaporates, it takes heat from the air, and it will evaporate. When you remove heat from the air, that leads to a drop in the temperature. So at the lower temperatures, everybody knows that the density will be better, right? You will have a higher density, right? Or you'll be having a more amount of, you can pull more amount of air, right, inside uh, more air inside the combustion chamber. So that leads to better power output, right, and better combustion. And ethanol has higher flame velocity, and it has a wider flame limits. So these are some of the good advantages, from SI engine point of view, that is, petrol engine point of view. So what are the modifications? If you look at, so these are some of the advantages I said. What are the advantages that you require? Now, what is the limitation, right? If you look at the limitation, ethanol is hygroscopic. I mentioned earlier, right? So the advantage is that it readily mixes with water. Most of you agree, right? Most of you agree. Ethanol and water are very good combination, right? They mix very easily, right? And so the problem is that when ethanol has higher water content, it will not properly blend with your fuel, gasoline fuel, right? A dry ethanol is readily mixable with gasoline, but what happens is that when the content of water increases in the ethanol, that leads to phase separation, right? You will have water, that is ethanol separated. You will have ethanol, at the bottom, and the gasoline will rise up, because of the density difference, right? So uh, uh, the hygroscopic nature leads to phase separation, so that is one problem. And the second problem, still, when this hydrous ethanol, right, we call it as a hydrous ethanol. This hydrous ethanol, when it reaches the engine, uh, uh, that can create corrosion, because of the water content in the fuel. It create corrosion in various parts of the engines, right? And the another issue is, the ice formation, right? I have we have that experience actually. It's we tried with the carburation. The carburation method, because of drop in the temperature, the moisture in the air, starts condensing first, and it becomes ice in the carburetor. So you'll have ice formation inside the carburetor. Suppose if you are using a carburetor method, yes, if you say that nobody is using carburetor, yes, I agree. But still, two wheelers, 90% of the two wheelers we use carburetors, right? And the next problem is the oil seals and the rubber components. What happens is that they are not compatible with the elastomers. They become brittle over a period of time. They become dry and brittle. When they come in contact with ethanol, right? And few rubber parts, will swell when they come in contact with ethanol. And the next problem is the compensation for a lower calorific value. See, when ethanol is used in higher percentage, maybe around 20%, suppose if you use it in the engine, we may require slight modification, because there will be a drop in the fuel's calorific value. So in order to compensate, you need to put more amount of fuel, right? So to achieve the same amount of heat, you need to put the more amount of fuel into the chamber, right? So this is possible only by slightly enlarging your injector size, right? Where you can achieve the delivery, or by going for a very high pressure injection system, right? So some uh, fuel line pass what is it modifications are required, so when you are going for higher blend of ethanol. And timing retardation, since it has a very good octane value, right? What we can do is, the retardation can be higher than the gasoline, and we can reach higher compression ratios parallelly. So the last two are the advantages actually, right? And the engine modifications that you require to accommodate higher blends of ethanol as a fuel engines. So on the next shell, I would say that some modification in materials, some modification in the fuel system, some modification in the ignition system, and the compression ratio can be accommodated, or can be implemented in order to accommodate higher blends of ethanol, right? Uh, in addition to the issues which I discussed earlier, there are a few more problems which I have not touched upon. One of the another important problem is, since the ethanol blended fuel has very less or no lesser calorific value compared to that of gasoline, we require a bigger size tank, right? For the same range. Suppose if you say that a gasoline you can do around 700 kilometer per filling, um, the same tank will lead to a drop in the range of the vehicle, right? So you need a bigger size tank. And the second thing is that if you look at um, the fuel consumption, it becomes higher. So you lose the fuel economy. The amount of fuel spent for per 100 kilometers per 100 kilometers is going to increase, right? So you require a bigger tank size, and at the same time, it leads to drop in the fuel economy, right? Ethanol will lead to drop in fuel economy. And the fuel indicators what we use today in the vehicle, that gives about the gasoline uh, is based on no according to the energy content of the gasoline. But when we use ethanol, then we need to do some modification, right, based on the percentage of ethanol that's going to change, right? So most of you agree with me. So if in the dashboard, if you look at uh, the odometer, you have an option. It tells with the present fuel quantity, how many kilometers the vehicle can do. Right. So on based on the average fuel consumption, it estimates the value and it will project. Right. You need to do modifications on the fuel indicators in order to accommodate ethanol fuel. Right. And the exhaust emission, if you look at the exhaust emission, you will have more amount of aldehydes that are present, though the quantity is very less. Higher ethanol may lead to higher aldehyde emission. Right. And not only that, you may also have ethanol slip. Some quantity of ethanol which is not burned may come into atmosphere. Right, through the exhaust. Right, and another big problem is the catalytic converter. The reason is that because of lower calorific value, the temperature that we can reach is going to be less. The exhaust temperature is going to come down. So your catalytic converter takes a lot of time to heat and to reach the lit-off temperature. So that is again going to tamper your emission, right? Cold start emissions, right? And the next one is the cold start trouble. This is very popular with ethanol. Right now, we do have suffered a lot during winter. It will be very difficult to start the engine with high blends of ethanol. So what we do is usually in our lab, we start with we'll have two carburetors. We'll start with gasoline, and then we'll switch over to the ethanol based fuel slowly once the engine gets warmed up. Right. So the cold start trouble is a classical problem with higher blends of ethanol, and reliability of materials. That is also another issue. Right, and coming to the emissions, these are the most important emissions. Since ethanol contains oxygen, you know that gasoline engines, they mostly run at stoichiometric ratio or slightly above stoichiometric ratio, right? And GDI runs now slightly above, but if you look at the MPFI engines, they run very close to stoichiometric air-fuel ratio. So what happens is that, suppose if we use ethanol, the additional oxygen may lead to generation of oxides of nitrogen, increase the generation of oxides of nitrogen. So there are both ways of literature available. Few say that it's less, actually oxides of nitrogen is less, and few have identified that it is increasing. Right, but theoretically, there may be a possibility of increase in oxides of nitrogen because of presence of oxygen in the ethanol, right? And other could be, the reduction of carbon monoxide because if you have already oxygen. So mostly, if you look at the reason for the generation of carbon monoxide is a mishandling of an air-fuel ratio, right? If it is too rich, actually, you will have carbon monoxide because of lack of oxygen. Coming to the next one is the evaporative emission. So ethanol also leads to evaporative emissions and crankcase emissions like your gasoline fuel, right? And very particularly, there are some studies which say that the crankcase emissions of ethanol, which contains um, uh, what is that? Combusted gases of ethanol may lead to corrosion inside your engine crankcase. Sometimes because of the presence of acids in the exhaust, right? Or the gases, burned out gases. So, that is again another issue that comes actually. I should have summed up on the earlier case, but this I want to give an overall picture. That's why I moved it here. Right, and again, another problem with the aldehydes is that you can't use normal HFID sensor to capture the percentage of or the value of aldehydes that are generated because of ethanol. So we need to use a special method actually by using a liquid chromatography. So in our lab actually we used liquid chromatography to identify the value of as what is that acetaldehyde that is generated by ethanol fueled engine. And that becomes a little expensive compared to that of the normal HFID sensors, that HFID analyzers that are available at the lab. And another very important, very interesting characteristic of ethanol is that it has higher electrical conductivity, right? So electrical conductivity is better than gasoline. Uh, it leads to process sometimes, something like an electroplating, right? We have identified, the material deterioration in the carbon. What is that? Sorry, fuel float, float chamber, right? That's very peculiar actually with ethanol fuel. And another disadvantage is from the safety point of view, ethanol burns with invisible flame. Right, only in the dark, you will be able to see. During the daytime, the flame will not be visible for you. When the ethanol is burning, it's a light, very light blue flame, which is difficult to see through a naked eye. Right, and the other issues are like your crash safety of higher ethanol blends and firefighting. These are going to be challenge when you are going to use ethanol in higher blends, right? And coming to the material compatibility, so we need to avoid materials like lead and aluminum, which are very susceptible for corrosion, right? So because of its electrical polarity, as I told you in the earlier case in the previous slide, and we need special materials, in the fuel handling side, in order to tolerate ethanol corrosion, right? So previously, when you look at um, that's during 2010, no, there was a green sticker, eat and ready, right? But I think now I don't know, I'm not seeing it in the vehicles. Previously I have seen that such stickers actually eat and ready, which tells that the fuel lines and fuel tank and what is the fuel system are compatible with the 10% of ethanol. So we need to change the fuel lines with ethanol tolerant material, right? So it's a continuation. Then I'm skipping. So I've given here what are all the materials that can be compatible with ethanol. And coming to the durability, right? Coming to the durability again, we have some mixed outcomes actually. At lower studies show that at lower blends, when you're using it in lower blends around 10 to 15%, there is no much difference in the wear. It's all almost same like your gasoline, but when you're going for higher blends, definitely there is a problem with durability, right? It is going to lead to erosion and corrosion, right? And which on the whole, it's going to deteriorate your performance of your engine, right? And see, this is related to diesel. So far, I told about gasoline. So yeah, and I also told that gasoline readily mixes with alcohol, right? Dry alcohol can be directly mixed with the gasoline, um, whereas diesel, the case is different. When you mix with gasoline, even a small percentage of water content in the ethanol can be tolerated, but the problem with the diesel is that even a slight uh, percentage of smallest percentage of in water in the ethanol could lead to phase separation, right? So it is it's good, it's always better to emulsify it. So they suspend the ethanol in small particles, right? So that requires a lot of heating, right, and stirring to break these ethanol particles into fine droplets and blend it in, put it in suspension, right? So we need emulsifiers which can make it to suspend small droplets, and co-solvents which can bridge, or which can be a bridging agent to bond, as a homogeneous blend, right? So one of the major or one of the successful co-solvent, is ethyl acetate. It's a good co-solvent, and even at low temperatures, it will not lead to settlement of ethanol, right? Coming to ethanol addition to diesel, right? Ethanol addition to diesel, since we are going to use in an emulsified form, uh, right? What happens is that it may lead to corrosion in the fuel pump, right? Or in the fuel line, wherever it goes, there may be um, corrosion because of water content in the ethanol, right? So another biggest problem is the lubricating oil's viscosity and lubricity. This is more prone to your diesel engines. You know that when the fuel, when it is injected, sometimes the fuel may go and impact the wall of the cylinder, right? When that case, what happens, ethanol that is present in the fuel can dilute your lubricating oil, and it can increase the friction, it may lead to aspiration of the metals, right? Right. So there are studies, which very clearly showed that the ethanol addition to the fuel can affect the viscosity of the lubricating oil that is used, right? So in one way, I would say that when the lubricity is affected, it not only it's going to deteriorate your engine performance, that is also going to lead to material removal from the cylinder, right? So the wear and tear is going to increase, when you use ethanol in the diesel engines. So in the summary, if you look at it's more corrosive, it's hygroscopic. You need to remove the plastic materials and rubber materials. It has very high latent heat. It has a cold start issue. It has a very high fuel consumption because of low energy content. And I didn't speak about the drivability index, because of lack of time. I thought I would discuss, actually, because of lack of time, I'm skipping it. Drivability index is also another important factor, that comes to issues with ethanol. Maybe you can find out in the literature. The next one is the cold start emissions and increased aldehyde emission. Um, it's going to definitely affect your catalytic converter, because the time to reach the lit-off temperature is going to increase, and you require fuel passage or fuel system modifications when you are going to use ethanol as a fuel. Right. Though we have a lot of issues, actually, as I discussed in the earlier section. Um, ethanol is still considered as one of the best biofuels that can be directly used. No need of trans-esterification or any other process like your biodiesel. It can be directly used. And again, I told about the ethanol production, but I didn't touch upon how the ethanol is produced because of the lack of time. I thought I can skip those content. Right. Mainly, if you look at in India, it is manufactured from molasses, or it is manufactured from the bio waste. Now we call it as a 1G or 2G, right? Now technology, right? Now, so based on that, either you are going to use uh, uh, sugar plant derivative or bio derivative that is available from a paddy field or an agricultural field, or even the vegetable waste that is generated in the market, and food waste that is generated in the hotel can be used to manufacture ethanol, right? So these are the major issues. And coming to the technologies which can be used for addressing the issues of ethanol. One is using very high compression ratio, which I already told you in the beginning itself. Uh, the next technology could be combining ethanol with other uh, uh, alternate fuels like hydrogen or bio CNG. This could address the issues like lower calorific value. It can improve the vehicle performance when you are combining ethanol with other renewable fuels like hydrogen and bio CNG. And in addition to that, there is a technology called as low heat rejection. This also can be implemented. This also can be implemented in an engine. Since I said that ethanol has a very low calorific value, you have a problem of temperature of exhaust, which is going to tamper the function of a catalytic converter. The exhaust heat can be improved by using a low heat rejection technology, right? Where you have the overall efficiency of the engine improved by 1 or 2% compared to that of non-LHR engine, right? The LHR stands for low heat rejection, right? So in one way, it is going to benefit your engine out efficiency, and in another way it is going to improve your catalytic converter performance. And the last one is the HECI mode of operation, and still people are trying to run uh, by combining ethanol and hydrogen to run it on HECI mode of operation, right? And this is low heat rejection technology. We used in 2006 or 7. We were able to achieve around E85, up to 85% ethanol. We were able to run with this low heat rejection technology. Right. So because of limited time, I want to stop it here. If you have any questions in your mind, I'm ready to answer. Sir, I think Chandrasekhar sir, I think I'm little late today.
No, sir. You are on time, sir. On time, as per the schedule only, sir. No issues.
Right, sir. Right, sir. Okay.
Sir, any participants, any questions? Any
Sir,
clarification
you
you can
mentioned
impart?
about the ethanol. Sir, you mentioned about the ethanol. Whether methanol is not suitable for SI engine or CA engine.
Sir, your voice is not clear, sir. Can you come again, please?
Sir, you were
Can
mentioned
you?
about the ethanol
Yes, sir.
usages. What
Yes,
about
sir.
methanol? Sir? Methanol is not suitable for SI
Yes, sir.
engine or CA.
Sir. Yes, sir. When I say that alcohol, mainly two types of alcohol are very popular. One is ethanol, and second one is methanol. Right? Methanol also can be used the major issue is that formaldehyde that is coming out of your methanol. Acetaldehyde is not carcinogenic, whereas formaldehyde is carcinogenic. And moreover, if there is a slip of methanol, that can lead to eye irritation or loss of eyesight, when you come in contact with your eye. So methanol is toxic. The other way, what I can say, that methanol is toxic, compared to that of ethanol. And you agree with me that we consume ethanol, right? Ethanol can be consumed. It's not so toxic like your methanol. So that's the reason why more thrust is towards ethanol instead of methanol. And moreover, ethanol can be produced from a bioderivative, whereas for methanol you need to use a different process, right? So that is the difference actually, why more push is towards ethanol. So
Sir,
is it okay, sir?
one more
Yeah.
question, sir, from the chat box. Ramesh Kumar, sir.
Yes, sir. Yes, sir. Please go ahead.
So which technology has a brighter future in case of whether it is blended fuel or electrical vehicle? Which technology?
Uh, so that is
Yeah.
a really very
Yeah.
difficult question to answer actually.
Yeah.
So right now, if you look at the scenarios, now we have a lot of issues with charging infrastructure, right? With present charging infrastructure, I think it will be very difficult for us to use EV, electric vehicles. That is one challenge. And the second challenge could be, even if we have enough charging infrastructure, the battery import is again going to do the same thing, like what you do for a fuel, right? Instead of fuel, you are going to import battery. So unless otherwise, we are self-sufficient with the battery technology, right? Now, if we manufacture the battery technology by ourselves, that is going to really a challenge. I would say that hybrid could be the bridging technology between the engine and the electric vehicle. So the next coming 10 years, more concentration will be on hybrid instead of electric.
Yeah, sir. Rightly said, sir. Rightly said. Because the
Yes, sir.
technology, we have to see the technology and we have to practice that. Then we'll be facing some problems. But IC engine
Yes, sir.
technology
Yes, sir.
already we
Yes.
are we are only thing, as you rightly told, that ethanol can be used from the reduction of emission perspective, and it has been also
Exactly.
proven. Okay. So in the near future, I think blended fuel will be sufficient, sir. It will do. It
Yes,
will.
sir. Yes, sir.
Okay, sir.
So definitely biofuels will one day it will come to the market. It will be commercially used, but it may take another 2 decades now to come to the market.
Yeah, yeah, yes, sir.
Yes. Yes, sir.
So
Any
if
other
there are no
questions?
questions, sorry, pardon me, sir.
No, if is there any other question? No, I'll be happy
No,
to
sir, no,
answer.
sir, no, sir, no questions, sir, no questions. So
Okay,
at this
fine,
moment,
sir.
I thank Dr. C. Ramesh Kumar for an excellent presentation, giving an overview of the ethanol-based blends and its usage for IC engine, and the statistics provided for various things. Nicely shared, sir. Very interesting session. And the main highlight is that on overall the generic aspects, not pertaining
Yes,
to
sir.
say
Yes, sir.
engine specifications or engine modification like that. It is an overall very nice and alternative fuels very apt presentation, sir. I thank sir for your presentation, sir, and your support, sir, for the conduct of this session, sir. Thank you, sir. Thank you.
Sir, from my side now, I would like to thank both of you, yourself and Gopal, for providing me this opportunity. I'm very happy that I'm also part of this ATAL FTP. Thank you, one and all, and I also thank all the participants who were patient listening for more than I think it's close to 1.5 hours. Right.
Sure,
Thank you, one and all.
sure, sir. Thank you, sir. Thank you, sir.
Thank you. Thank you.
Thank you, sir. Thank you for joining, sir. Thank you.
Thank you, sir. Thank you, sir.
Dear participants, I think we have come to an end of day 3 of this FDP. Before we close, I've already posted the announcement in the chat box. So we noticed that there are some discrepancies in the email addresses. Okay, kindly ensure that you have the same email ID, also the number name also. So, okay, somebody is putting in a different way. Okay, so initials and for name. So be consistent. So we are facing some problem while we see the while we take the data for your attendance. So we'll restore that, no problem. So anyway, it will be better if you have some consistency while you enter your name and the email address. Thank you for joining. Any other queries or any clarification, sir? Okay, if there are no queries, no doubts, good. Thank you. Thank you for joining us. Let us meet again tomorrow morning by 9:45. Thank you.